Can you see that?
Yep.
Okay, so hi, my name is Rahul. I'm part of the cloud identification team, along with Yuping, Neil, Andrew, Prarthan, and we're going to be discussing our project which identifies clouds.
So the reason we made this product is because clouds are some of the best indicators of weather. Typically, when we think about clouds and weather, we only think about rain, like the image over here, and about the clouds getting dark, which symbolizes rain. However, we wanted to expand the scope of what people could do based on identifying the type of cloud, because knowing the type of cloud can actually tell you quite a lot about what the weather is and what it can be later on. For example, cumulus can indicate fair weather, while cirrus means that the weather will change in 24 hours, while stratus means that it's cold, misty, rainy, or snowy. Next, many people simply don't know about the five basic cloud types. I'm sure we've all learned about this in 2nd or 3rd grade, but getting back to knowing it is part of the fun and also helps you appreciate it because you know the name of it, and being able to identify the cloud is also part of the fun. Lastly, knowing the names of the clouds can help you not only appreciate them more, but also know about the other 5, because there can always be a subset of them. And there's 10 clouds total, all of which branch from the 5 main clouds, and they can all be identified. So over here is the 5 clouds we try to identify: stratus, lenticular, cumulus, cirrus, and nimbus, all of which, as previously said, can be used to predict the current weather and what it will be later on.
So again, there are 5 potential labels. So we got our data sets by pulling the images from the internet using search engines. And then for each cloud type, we pulled about 1,000 images. And then to process our data, we use label box. We manually identified the different cloud types. So you see on the left part of the image, there are the different labels. You click on the label and then you create a box over a cloud that you've identified. One example data process is this image right here. Here there are 5 different labels. There are 3 labels for Nimbus clouds and then 2 labels for Stratus clouds. And in total, we made over 5,000 labels.
So we identified objects using the yellow object detection algorithm, and it uses convolutional neural networks to identify the objects. And so why we chose yellow, it has the ability to predict objects in an image based off a single run of the algorithm. The algorithm also has the ability to make predictions in real time. It's extremely accurate and extremely capable in learning object features and applying them in real-time predictions. And basically the 3 main parts to it, detecting objects is through the use of residual blocks, bounding box regression, and intersection over union, aka IOU.
So along the way when we were making this, we did have some difficulties, and the main difficulty was in the accuracy of our model. So when we looked at the confusion matrix, which shows the relationship between how many predicted guesses were correct and everything else, we realized that our model did have sufficient accuracy, but not great accuracy. So what we did was we made sure to revise our images that we made in label box by expanding over the clouds that we needed to go over, because at some times we were a little bit conservative, trying not to hit the image watermarks, and that cost us a little bit of accuracy. However, after we revised that, our accuracy did increase.
During our course, there were many new concepts that we were taught. Our instructor led us through the basics of Python, for example, lists, modules, pandas, scripting, and strings. In addition, there were also many mornings where we had lectures relating to AI concepts, covering topics such as deep learning and machine learning, and being taught how to view the performance of our AI model through a confusion matrix by means of percentages and learning about probability. Recently, we deployed a website featuring our AI model, learning about concepts that may be familiar to some, like HTML and CSS, and other concepts that may be fairly unfamiliar to most of us in the team, like Flask and the relation that file directories have with the various files that contain the code we had to adjust for our website. In the process of labeling our data, we understood the purpose of trying to include labeling all clouds in the picture And it's important for AI models to have good performance because based on our first round of model training, there was actually a pretty high percentage of clouds that were not being detected. This led us to value detection over no detection for our cloud pictures while still aiming for high accuracy. So there was actually a large number of clouds that our algorithm predicted, but which we had not labeled. You can see on the left confusion matrix in the last row, where the label on the left saying no detection, which represents all the clouds that we missed while labeling our data, corresponded to a high percentage of clouds that were actually detected by our model. This was not ideal for our model performance, so we had to go back and relabel our data as we mentioned in our difficulty slide. After making the adjustments on our labels, our model's performance improved overall, where you can see decreases in the majority of the boxes in the last row of the confusion matrix on the right. Increases in the accuracy of cloud detection in general improved, which you can also refer to the percentages in the boxes that correspond to the same labels. For example, clouds that we labeled as Stratus clouds, you can find that category among the labels on the left of the confusion matrix, and those very same clouds being detected as Stratus clouds by our AI model, which refers to the Stratus A label, towards the bottom of the confusion matrix will be shown in the box that is on the top left-hand corner in our updated confusion matrix.
So now we're moving on to our demo. During our project, we created a homepage for our website. Here is the homepage, and here we included pictures of the various different types of clouds, which were said before. Here we have cumulonimbus, cirrus, cumulus along with Nimbus. And here's our mission statement, which was said by Andrew in our presentation, which is why we chose clouds as our project. We also have our team and our professor who instructed us about the basics of Python, along with teaching us how to use labelbox and cocalc. Now, if we click the Try Now button, it allows us to choose different images which are saved on our computer. The first one that we have is cirrus. And as you can see, it draws boxes around the different types of clouds and also states accuracy and confidence in how the program chose our cloud. So the first box was 98%, then 89%, 71% and 57%. So it's decreasing in confidence because of an increase in the number of clouds in the picture. Now we can use this for not only cirrus, but also stratus, lenticular, cumulus, and nimbus, as I'll show you one picture for each. Here's cumulus, along with the confidence for the various different boxes that were drawn. Lenticular. And as you can see, there's another cloud here which isn't drawn, which doesn't have a box drawn around it. This is because not only was it not in the images that we had, not only did we not have a cloud with that particular color, so the program wasn't able to identify it as a type of cloud that we had in our register. So that's a problem that we need to fix going further on if we were to improve on our project. Here's a picture of a Nimbus cloud. And lastly, our final type of cloud is Stratus.
To win it. Right, but see, and I'm not offended. Robert